Hi, welcome to another edition of Math with Mr. Douglas. I bet you're wondering what we're going to be tackling today. Well, we'll be looking at what is a function. And in the challenge section, we'll be starting to look at quadratics. And the first part, which is the axis of symmetry, and finding the all-important vertex. Alright, superheroes, are you with me? Take out your lassos and let's go and fight some crime and find x. Here we go. Functions. Yes, we are talking about f of x. That is going to be exciting. We have just finished looking at things that are like y equals mx plus b, and now we are going to confuse you and we're going to do functions, which I must tell you, it's the exact same thing. Okay, so no worries here. Instead of saying y, I'm just going to say f of x. Okay, so that's the very first thing, that f of x is really y. If you have that down, you can just stop the video right now and go and do something else, because you have learned everything that you really need to learn. A little bit that will help you. A couple things. This is pronounced f of, oops, not or, f of x. And functions can be of different kind of values. So it's saying like when x is this, y will be that, basically. And that's kind of cool. And to kind of expand on that, if you wanted to say, like say we're talking about a function like f of 2 for f of x that is, say, 2x plus 4. What would that be? Well, I'm just saying take this and just put that right there. Well, okay, so 2 times 2 plus 4. So f of 2 would equal 8. Kind of makes sense? So y equals 8. So y equals 8. That's kind of what we're talking about here. So that's kind of the idea. So functions, same thing. Nothing too complicated. A few things, though, we do need to know. There are some rules. Number one, to be a function. To be a function, we'll say this, every input has exactly, you probably want to bold that word in your notes, exactly one output. Okay, so that makes sense. Every one input has exactly, I'm going to put a little box around that. So what they're going to show you are these things called like maps. So maps. So here's my map of, say, x, and here's my map of a random y, let's just say. So here's my x's, 1, 2, and 7. And over here I got like 2, 9, I don't know, 18. I'm going to say when x is 1, it's going to be 2, and say when 2 is x, y is 18, and 7, let's say it's like that. Okay, let's say something like this. Right, so every input, so the x's are our inputs, these are our inputs, so these are inputs, input. And then we have our outputs. So when x is 1, we'd say when x is 1, y was 2. We'd say when it was 2, it was actually 18, and then when it was 7, it was 9. Okay, so that's kind of what we're saying. Every input has exactly one output. But there are some things that do happen when the opposite happens, basically. So let's take a look at those. What happens when your inputs have more than one output? So what do I mean by that? Well, what I'm talking about is, say it was like 2, 8, and 10, and let's say here you had, I don't know, 11, 15, and 20. And I said, when x is 2, it could be 11, or it could be 20. I'm not quite sure. So that one input has 2 outputs. Now that cannot happen. Okay, so that is not a function, not a function. Okay, really important. So every input has to have exactly one output, but there is the opposite case. So let's just say You had this though. What about this one? This one always, this is what teachers will give you. They'll give you that option. Maybe I should have kept that. Maybe I will keep that. So this was, I think this was 11 or 20, I said, right? But what happens if an output has two inputs? What does he mean by that? That sounded crazy. But what if it went like this though? 2 is 11, but 8 is also 11. Oh heck, so is 10. 10 is also 11. What, is that okay? Well, does every input have exactly one output? Absolutely. But the outputs have more than one input. Yes, but that's okay. So that is a function. Yes. A function. Okay, so, well, how could that happen? Well, think about it this way. What is the absolute value of x? Let's say if this had to be 5. Okay, so the absolute value of x. What could this be? Well, it could be 5, or it could be negative 5. Okay, so that is one way to look at it. What about as a picture? What does it look like if it's a picture? So some people are like visual learners. Like, what does it look like? What does it look like, Mr. Douglas? Well, we can go and do something called a straight line test, but I also call it the finger the finger test. So that sounds horrible, doesn't it? It does. So this is an important drawing to get right. There we go. There we go. Okay. There we go. It's important that you will use this finger. Okay. There we go. And all you're going to do, it's like one of my better diagrams, is you are going to drag it from left to right across your piece of paper, and you are going to see if that actually crosses the blue line exactly at one place. So just think about it. You can take your finger right now and go across your screen. Does your line exactly cross it at one point? Yes, your finger crossed the line exactly at one point. It absolutely does. But like, so what happens if it was, say the line was like, I don't know, this. Say it was a cool thing like that. So imagine you had your hand going across this one. And if you did, so here is your very large index finger. Let's just focus on that. So there's your, oh, I'll draw the rest of the hand. Why not? There we go. A little pinky and the thumb. There we go. It's a great hand. And you can see right there that it crosses at two different places. It crosses here and here. So that is not a function. That would not be a function, because what it would be saying is that when x is, so like let's say I looked at these 2 points, right? So say I looked at this point. So when x was, say, -3, your y values could have been 7, or it could have been like -2. Who knows? And that means one input has 2 outputs. You can't have that. That's what that means right there as a picture. So that's kind of important, and really that's how you tell if things are functions or not. Use a straight line test. One input has to have exactly one output, and you're good to go. In the challenge section today, we're starting to look at the first part of quadratics, which of course is the axis of symmetry and figuring out that little vertex point right there. What do you say? Should we start looking for it? Here we go. Okay, so we're now looking at quadratics. And just as a quick little review, when we were talking about kind of linear equations, so that was y equals mx plus b, and you get really cool graphs that were basically just straight lines. Now we're going to be looking at quadratics. So we're basically looking at things that are ax squared plus bx plus c is equal to 0. And this is where we're going to be getting those U-shaped parabolas. Okay, so today we're just going to look at something called the axis of symmetry. So the axis of symmetry is basically the line that splits a parabola in half. So the axis of symmetry, pretty important. and then the other part is going to be the vertex. So to give you an idea, so the axis of symmetry in the vertex, so if this literally was the parabola, that's a horrible color, let's choose blue. There we go. There's the vertex. So the vertex is the bottom or topmost point, and then the axis of symmetry is just if I was going to go and split this down there. Remember in art class when you were a kid and your art teacher had you like draw your face and you had to put a mirror halfway in there, and then you saw that your nose was like this and your eyes and that kind of stuff. You had one eyebrow, maybe you had the other eyebrow, I don't know, and then you had like a little face and you had that. So the axis of symmetry kind of splits things in the middle. Okay, so imagine that you're just figuring out the axis of symmetry and stuff. So that's what we're gonna be looking at. And again, this is only the first kind of part we're gonna be tackling. So some of you might have some more knowledge about quadratics. This is the first part that we need to kind of tackle. So let's just say you had something that looked like this. So x squared plus, what's that, 2? X squared plus 2x minus 8. So you had something like that, and then you had to go and find what is the axis of symmetry, and also what's the vertex. So that's what we're talking about. A couple of things to kind of look at is, first off, the a value, which is right here, you don't see it, is 1, and it's positive, which means your parabola is going to open up. It's going to be a happy face. So it's going to be a happy face like this. If it had have been negative, it would open up negative and down. So like that, to give you an idea of that's what we're talking about a little bit, and that will help. Not really the scope of this video, but just as an FYI. We're going to learn formula, so this is formula time. We love formulas. Yay! So we all like formulas, and the formula, if we're taking a look at stuff in terms of the axis of symmetry, is we're going to be taking a look at this one, and here it is. Drum roll. If you're a drummer, you're drum rolling. It's negative b over 2a. So we're talking about negative b over 2a, and that means we need to go and figure out what our letters are going to be. So we have a, b, and c. So our a, again, is right here, so that's going to be 1. Our b is 2, and our c is negative 8. You don't need that for the formula, but I'm just going to put that out there because it might come in handy later. So if I had to go and say that, so negative b, so it would be negative 2 over 2 times a, which is just going to be 1. Okay, so we plugged in all the numbers, your b and your a, and notice I should put brackets around this one because that's going to be really important later on. So we just go and kind of do that, and obviously if you just do the math, you get negative 2 over 2, which is going to be negative 1. So that is what we call our axis of symmetry, not the axis of allies, which is a fantastic board game for you board game fans out there. That's our axis of symmetry. So if we go take a look at, what would that look like in terms of our graph. So here's our graph, and if we kind of go back to the axis of symmetry is negative 1. So on our x-axis, we go and find out where negative 1 is. There it is. And we know that that is going to be the midpoint of our vertex. So our vertex is going to be somewhere along here, and we also know that our graph is going to be opening up. So it's going to be something, whoops, let's go and get rid of that. It's going to be something like this. Now, I don't know exactly where on x is negative 1, where it's going to be, but I know it's going to open up. I know that much. So now we need to go and find out, though, is what is our y value? And if we know to find out what the actual vertex is, so we kind of go back to here, and it was x squared plus 2x minus 8, so x squared minus 2x, so x squared minus plus 2x minus 8, right? And we knew that x was going to be negative 1. We know that. And we know that vertex is going to have the coordinates x, y. And this all equals, we always say it equals 0, but I'll be very honest, it kind of equals y. Okay? Let's kind of get that idea there. So I'm going to go and plug in -1 into this. So let's go, and I'm going to kind of write it like this with some brackets just to kind of get used to that. Equals or y. So I'm going to go and put that -1 in there, and the brackets are really important because -1 all squared is just going to be 1. So we're going to do that, and we're going to get 1 minus 2 minus 8. So 1 minus 2 minus 8 is going to be -9, and that means our vertex would be -1 comma -9. So on our graph, our wonderful graph, I would go find where -9 is. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there's -1. So there it is. And it basically opens up. Whoop. And it opens up kind of just like normal. We'll talk more about intercepts. You know, you might be thinking like, oh, I need to go and find where the x-intercept is and where the y-intercept is. Well, those are really important points, but we're going to save that for another time. Let's go and take a look at one more question, just to kind of be clear on everything. And the question, let's get rid of that one, and let's go and take a look at this one. Is always going to be good. X squared minus 6x plus 3. Now I know you're already saying, oh, this is going to be a tricky one because of the -b over 2a. And we know that our a is going to be 1. Our b, though, so our b is going to be -6, and our c is going to be 3. Okay, so let's go and plug it in. That's actually pretty not too bad. So -b, so -6 over 2 times 1. That's nice and easy. So that's going to be 6 over 2, which is going to just be 3. Now remember, that is our axis of symmetry. So we know if this is our thing, it's going to be crossing the x at the 3. So our axis of symmetry is going to be here somewhere. It's going to be opening up, but we want to go and find what, by chance, is our y going to be. So I'm going to go and plug in the 3. And I'll plug in the 3 here, plus 3. So I'll get 9 minus 18 plus 3. So what's that? -9 plus 3. So I get -6, I believe. And that's going to be my y coordinate. So I'm going to get a 3 comma -6. So that's going to be the vertex. So it's going to be down here somewhere, and it's going to open up just nicely like this. It's going to be opening up, and there we go. So the vertex and the axis of symmetry, the first step of learning about quadratics and parabolas.
Thanks everybody for tuning in to another edition of Math with Mr. Douglas. Hope you've learned a couple of things. Until next time, be an awesome superhero. Cheers.